Well, good morning. It is another cold day, and I thought what I might do is to make a little video for you to explain Lewis dot structures. That's what the title of this little video is going to be about. Now, Lewis dot structures. Lewis is a chemist that lived around the 1900 time and was very influential in determining the shape and the structure of molecules. And this is important because the shape or the structure of a particular molecule or particle is going to determine its chemical and physical properties. And that's important when we want to know why certain biological molecules or medicinal molecules act the way they act. It's all going to be determined by their shape. And so the way that we do that is there's a procedure for drawing these dot structures or electron dot structures. And you'll take a look at the first I can statement here, that I can draw a Lewis dot structure if I'm given a molecular formula. That's our goal here. And it says here that a Lewis dot structure is a diagram that shows the electron structure in a molecule. So what we're trying to do is to show the way that the electrons, the bonding and unbonding electrons are arranged in a molecule. And we show shared or bonding electrons with a line, and we show non-bonding or unshared electrons with dots. That's kind of the way that works. So here are the rules. There are 5 short rules, and what I'm going to do is to go through this and then we'll apply it in some examples later. The atom with the lowest electronegativity is going to be our central atom, always. And hydrogen is never going to be a central atom. Hydrogen can only make one bond, and so we can't put it in the middle of a molecule. Number 2, you draw dot diagrams for each atom in the formula. Now in Schoology I have created a couple of links to help you with dot diagrams. We will also talk about this in class. It's a pretty easy idea, but it is probably foreign to you at this point. Number 3, count the number of single electrons from the dot formulas and then divide by 2. This number equals the number of bonds that you will have in your structure. If you're drawing a polyatomic ion, it says to reduce the number of bonding electrons by 1 for every negative charge and increase the number of bonding electrons by 1 for ammonium, which is a positive charge. Fourthly, draw the molecule with all bonding pairs shown. That's with all lines here. Then add unshared electron pairs to satisfy the octet rule. For our purposes, all the molecules that we're going to draw follow the octet rule. So all atoms are going to need to have 8 electrons around them. Hydrogen only needs 2 electrons. There are exceptions to the octet rule, but for the scope of this class, we're going to limit it to just elements that are following the octet rule or molecules. And then finally, number 5, add up the total electrons in your structure and check to see if this equals the number of electrons from your dot structures. Okay? That's the procedure that I'm going to walk you through. I think there's 3 or 4 examples here. Okay. With electronegativity values, you have a chart in your notebook. I know a periodic table of electronegativity values. We are only going to worry about a select few because in covalent molecules we were dealing with just, if I draw this line in here like so, it's the nonmetals and probably hydrogen. Hydrogen is 2.1 if I remember. So the elements that we are most primarily concerned about are these elements right here. These are the ones that you're going to be using over and over and over to figure out which element has the lowest electronegativity value. And I'll refer to this when I'm trying to make that decision. Okay, so you might want to mark on your chart in your notebook what you see here. Okay, water, H2O. The first statement said the atom with the lowest electronegativity. Well, hydrogen is the lowest electronegativity, but guess what? Hydrogen can't be the central element, so oxygen is going to be your central element. Okay? Secondly, it says to draw the dot structures. Well, hydrogen has one valence electron, so I'm going to put one dot. And we've got two hydrogens, so that's what we have there. Oxygen has 6 valence electrons, so I go 1, 2, 3, 4, 5, 6. Okay? That's how I do that. Now, count the number of single electrons. Well, the number of single electrons, you got 1 there, 2, 3, 4. So I have 4 divided by 2 equals 2 bonds. So I'm going to draw my central atom. I'm going to show my bonds with a straight line. I'm going to put the other element on the outside of that. And then what I need to do, the fourth one says, draw the molecule with the bonding pair shown, add unshared electron pairs. Okay, oxygen, you'll notice, has 2 electrons, 4 electrons. It needs 2 more. Okay, so now oxygen has 8 electrons around it. Hydrogen only needs 2 electrons, and each of these lines count for 2 electrons. So it looks like everything is satisfied here. The final thing I'm going to do is I'm going to check. From my dot structures, I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. And I have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this is a Lewis dot structure for water. Okay? And when we get into this a little bit deeper, we'll start talking about the actual shape that this is going to be drawn in. Right now, I'm not going to attend to the shape. All right, moving on. CH4. Again, hydrogen cannot be the central element, so carbon has to be the central element. And my dot structures, whoops, let's try this. Hydrogen is 1, 1, 1, and 1. Carbon is 1, 2, 3, 4. Okay? Now count the number of single electrons. 1, 2, 3, 4, 5, 6. Whoops, let's count it like this. 1, 2, 3, 4, 5, 6, 7, 8. And you have 8 divided by 2, which is 4 bonds. So I have carbon, 1, 2, 3, 4, hydrogen, 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 and hydrogen. Is the octet rule satisfied? Yes. Carbon has 2, 4, 6, 8, and each hydrogen has 2, 2, 2, 2. These shared pairs go for each atom. Okay, so that finally I'm going to count. I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons, 2, 4, 6, 8 electrons. We're done. That's the Lewis structure for CH4. How about NH3? Again, hydrogen cannot be the central element, so that's going to be nitrogen. And I draw my dot structures. Hydrogen has 1 dot, 1, 1, and then nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. Now count your number of your single electrons. 1, 2, 3, 4, 5, 6. So I have 6 divided by 2, which is 3 bonds. Central element is nitrogen. 1, 2, 3, hydrogen, hydrogen, hydrogen. And to fill out the octet rule, I didn't need that mark there. We have an unshared electron pair here. Again, count the number of electrons that you have. I have 1, 2, 3, 4, 5, 6, 7, 8. Octet rule is satisfied. 1, 2, 3, 4, 5, 6, 7, 8. There's your Lewis structure for ammonia. Having fun yet? One more. Okay, last example, carbon dioxide. Carbon is the lowest electronegativity element, so it's going to be your central element. And so if I draw my dot structures here, carbon has 4 valence electrons. We show it like that. Oxygen has 6. 2, 3, 4, 5, and 6. And again, we have another oxygen here. 6. Now if I count my single electrons, I have 1, 2, 3, 4, 5, 6, 7, 8. That's going to be 8 divided by 2, which is 4 bonds. Alright, so let's draw it. Carbon, 1, 2. Now, I can't put a bond here or here because we only have 2 oxygen elements. And so either I'm going to make a double bond here or a triple bond and a single bond, and what makes sense here is some symmetry. And so what I'm going to do is I'm going to make a double bond here. Now, does that satisfy things? Well, carbon has 2, 4, 6, 8 electrons. That satisfies the central element, and let's add unshared electrons to satisfy our terminal, or oxygen. Okay, so oxygen has 2, 4, so 6, 8. 6, 8 here. Does that show how many electrons that we have? Well, let's take a look. We've got 4 and 6 for this oxygen and 6 for this oxygen, so I have a total of 16 electrons. And down here we have 2, 4, 6, 8, 10, 12, 14, 16 electrons here. This is your structure for carbon dioxide. So just to re-emphasize here, if you make single bonds and you still have more bonds to make here, the doorway is open then to be having multiple bonds or double bonds with elements. Now, oxygen is a great element that you can make double bonds with. It wants 2 bonds. So we'll talk more about this, and especially in your lab you'll see this again. Hope this helps. See you in class. Thanks. Bye-bye.